All right, so welcome back, everybody. Today, we are going to continue on where we left off. So, last class, we talked about 4 basic operations. Just to remind me, you don't need to write it. I just want to see it. If we wanted to do something like f plus g of x, how does this expand? F of x plus g of x. And I can do that with plus or minus. I can do it with times. I can do it with divide, right? Those ones are pretty straightforward. And then towards the end of last class, you guys didn't have any additional, I guess Thursday, because we had the assembly on Friday. We talked a little bit about this composition of functions. Now, when we compose functions, we talked about this mapping where I go from the domain of g to the range of g, and then we plug in those values into a new function called f, and it just does this next mapping. So all we're going to do is we're going to define this real quick, and we'll just say we are putting one function, and this language is fairly informal, but we're going to use this consistently. Putting one function, quote, inside of another. Now, it's a fancy way to combine 2 functions by putting one inside of the other. Now, the reason that we would do this, just as you guys are getting caught up, is if I have one function that goes from here to here, and then I have another function that goes to here, it would be much nicer than plugging in 2 different values, or conceivably a bunch of these, like here to there to there to there. We could keep going. It would save us a ton of time if we just had a way to do that. Would we all agree? Like, one thing is easier than 2 things pretty normally. So with that said, we are going to sneak in our definition for these. So here's like the nice way to do it, but we're going to write it out. And just like we started f plus g turns to f of x plus g of x, we're going to start every problem using composition as follows. We're going to sneak this in first, but we're going to say, e.g., just as an example of this, if we wanted to compose 2 functions, and I'm going to specifically use different colors, let's say we did f composed with g. So we have 2 different functions, and it looks like it just says fog, and that's okay. It's the degree symbol, but just pushed down in the middle. This thing is straight up read f composed with g of x. Now, those of you that are in geometry, and everybody has taken geometry, have we seen this symbol show up in geometry? Where? It's not multiply. When we're transforming stuff, transformations, we have a move left or right, and then we can dilate it or we can reflect it. It just tells us this happens in order. With this, wording-wise, it's kind of ugly. This part right here is read f composed with g. Now, for these functions, this is a pretty common way to write it, but I'm going to be honest, it is not the most convenient way to write this. Rather than just doing f composed with g, can we all agree which of those functions, f or g, is closer to x? Like physically closer right now? G. So when we do this, we're going to do which function first? G happens first. The nearer function will happen initially. So when we expand this, I'm just going to use this, putting one function inside of another. It's a way to combine them. And let's just see what this is instead. This is a good first step, but what I want us to work to is we'll do f of, and what do we say that compositions do? They put one function where? Inside of another. So f was on the outside, so it's on the outside here. What is the inside part, do you think? G of x. I would encourage every single time that we do a composition, I want us to write, here's the composition first. This is our first step. Now, to work with these, the actual calculation of them is not terrible as long as we can see what's happening. Anytime that we evaluate a function, when we're told f of whatever the number is, we just replace every x with that number, right? And just to make sure we're all on the same page, you do not need to write this, but I do want to talk about it. If f of x is x squared plus 1, how would I find f of negative 2? So anywhere that there's an x, I'm just going to put a negative 2. Do the parentheses matter? Big time. So this is how we would evaluate that function. Is that a shock to anybody? I hope not. Like, that's how we've been evaluating them all year. Now, as we look at this one, we're going to clean up the language here. F composed with G is fine. And I'm just going to say equals. There is a more natural way to say this. Hawaii, what do you think this is going to say? F of, what do you think is going to be the second part? F of G of X. Boom. And we have it. Now, these are the same. This is just how we expand it. It's our nice rule. I don't think we've ever dealt with this before. So, using these rules, let's go ahead and knock one out. So we'll do an example, and we're going to do a couple different things. If you want to use color coding stuff, I have tons of color pencils. I would encourage it. It helps me in my head. It might help you. If you're okay without doing it, I'm okay without you doing it. We're going to compose a couple functions. So let's say we have two functions. F of X is, what do you want this function to be, Zed? Make up any function that's not just a constant. I'll make it easier. What's your favorite function? That's fair. Like, I didn't expect you to have one. What degree do you want? Do you want a 12th power? Okay, sure. X squared plus 3x. We'll call it that. Okay, g of x. Let's make this a lovely linear function. G of x, we'll say is, I don't know, 3x minus 4. So we just have two different functions that exist. Okay, no application here other than we're just practicing with these this operation, and then we'll see an application of this here in just a minute. Here's what I want us to do. And I really am considering giving you guys the first one, but I really want to model this one time. So we're going to go through one together, and then we're going to split. I'm going to give you guys some challenges. Should be a pretty chill lesson with some time to work on the end. For the first one, I want us together to find F composed with G of X. And I should have had black in there, but that's okay. Now, in this particular setup, I don't like the way that this shows up. RJ, which function, F or G, are we going to do first, do you think? So which one's closer to X? G. This is going to be our first function that we deal with. Now, that form is hard to think about, but I have a way to rewrite this. Instead of writing F composed with G, which is kind of a challenge to think about, how can we write this using the definition that we have up here? I can say that this becomes F of what? G of X. I don't know who it was, but I love that I heard it. Before we continue on, it gets ugly for just a second. Have I lost anybody here? Are we sure about that? Okay, so let's just go a step further. We're just taking small steps to make sure we can avoid mistakes as we're looking. So going through this one, my next line, and I'm just going to have a bunch of equals here because we're going to keep expanding, and I don't want to have to keep changing colors. This becomes F of, what's G of X? 3x minus 4. And I'm literally just plugging in the G, right? Exactly where it was. This thing means, and I'm going to make a note for this. I would encourage, if you need this note, have this note. Anywhere, there is an x in f of x, and we're going to plug this in to f of x because that's now what we're evaluating. We replace x with what? According to this. You're right, it's g of x. What specifically in this problem am I going to plug in for it, though? Love it. Angel says 3x minus 4, and all I'm doing is the same thing we did in pink above. If I'm finding f of negative 2, everywhere there's an x, I just replace it with a negative 2. This looks a little bit uglier, but it says anywhere that there's an x in my function f, which hence the color coding, anywhere there's an x, I'm going to replace it with 3x minus 4. Love it. 3x minus 4. Now, I'm going to put parentheses around it, and I would encourage, and in fact, I'm going to require that we put parentheses around when we substitute it in, because if we don't, we're going to run into some real big problems real quick. Okay, How many of you guys are comfortable with foiling stuff out in here? I would anticipate that everybody's hands are up, just so you know. Distribution stuff. We're going to see. I got like 4 hands up, but I am 100% confident that there's more than 4 people in here who are comfortable doing that. Okay, in my function f of f, we just said anywhere that there's an x, I'm going to replace it with 3x minus 4. So I notice there's an x right here. So check it out. I'm going to put parentheses. There's like the x that was squared. And I'm going to add to this 3x. Why am I leaving just big, awkwardly open parentheses here? What goes in each set of parentheses? 3x minus 4, just like we would do it if we were plugging in a number. Awesome. 3x minus 4 goes here, and 3x minus 4 goes here. What I want you guys to do is I want you to not act like freshmen. That might be a hint, just throwing it out there. I want you guys to expand this, check with your neighbors, work with your neighbors, work with me or Miss Sweet if you catch yourself in struggles, but you're going to have ... equals, and I want to see what you guys come up with. If you finish before some of your classmates, we're going to go a little crazy because I want you on the next one to do G composed with F. If you finish early, G composed with F in colors of X. Cool. I'm going to give you guys a moment. I want you to expand this. Only start B if you finish early. Talk it out. Work with one another. Let's see what we come up with. Quick question. I made a comment about you guys not being freshmen. What was that for? And what is freshman's dream? So it's another one of those things where you can say the answer, but if you're not really quite sure what it means, then I don't know if you really know the answer, right? And that's a whole philosophical thing. Foiling wrong. People always want to look at this and just call it 9x squared minus 16. But that's not true, right? Because when you square something, you multiply it by itself. Now, if we are foiling this, and we're going to do a little bit of scratch work if needed, and you must do scratch work. If you guys struggle to foil in your head, it's okay. Like, I don't mind. But I'm going to do a little bit of scratch work over here. What does it mean when I have 3x minus 4 squared? 3x minus 4 times 3x minus 4. Now, if we actually view the square as making this happen, I'm going to expand it maybe a little quicker than you guys can, and I'm just going to switch to one color at this point. How many x squareds? 9x squared. And then the next term is going to be what? Minus 12x, which lets me write minus 24x. And then finally, plus 16. All of this just became all of this. Okay, we have to expand it. If we just cheat through it, and I'm not like academic dishonesty cheating, just incorrect math cheating is all I mean by that, then we're going to run into troubles. How about this next part, which I'm going to change colors just so we can see the difference, plus what? 9x minus 12. Now, we're not trying to solve anything here other than get this into the most simplified form. So let's just see if there's any like terms that can combine, and if there are, we're going to deal with them. There's only one term that has an x squared, right? No other like terms. So I'm going to really lightly cross it out just so I know that I've hit it. 9x squared. And we're not really getting rid of anything. I'm just keeping track of what I've already dealt with. Okay, let's look for all the things with just x. We have a negative 24 and a 9. If we add negative 24 and 9x, what do we get? Minus 15x. And I'm going to really lightly cross those out. There's only one more term. Plus 4. Now, Perscovia asked a really good question. She goes, I don't know, and I'm sorry if you didn't want people to hear this question, but it was a great question. She says, I don't know how this goes back to what we looked at on Thursday when we were looking at these mappings. And I just want to try something real quick. Let's pick some value, any value. Like, let's do 1, and we're just going to use these functions. And I'm going to put them up on here. Is 1 a number that we could plug into my function f? Can I plug in a 1 here? So I'm going to do this one in like obnoxious, green, and large. I can plug in a 1 into either of these functions. Now, in ours, and I misspoke, which happens first if we're doing f of g? So which one's closer to the x, Lando? G. So we're going to do g first. So let's check. If I plug in 1 into g, what do I get? 3 times 1 is? Minus 4. So do we agree that if I plug in a 1 into g, it spits out a -1. Can I now look at this and go, oh, a -1, can I plug this into f? And let's just see what we get. If I plug in -1 into f, what's -1 squared? 1 minus 3. So we had 1 minus 3, and I think we got -2. And we might have had some goofy values when I was doing it a second ago. Did we get the same thing? Oh, never mind then. Okay. Now, was that super hardcore, like difficult to just plug it in twice? No. Can you imagine uglier functions of what we're working with now, though? Like there's uglier functions in these. And I just want to check something. If this is what we call f of g of x, we're just going to check and verify. And this is only for comparison with what I just wrote above. So if you're adding that in there, it might help. If I try to do f of g of 1, since this is f of g of x, it'd be like plugging in a 1 here, right? What's 9 times 1 squared? 9 minus 15 times 1 minus 15 plus 4. And what do we get? -2. If we just check what we did with our two-step process by just plugging it in, did we do the same thing in one line here? Yeah. Now, again, in this specific situation, you may not see the full utility of working with these, but if we accept that there's uglier function than these that exist out there, and we might tie more than 2 together, we might do f of g of h of s of r, and like we might link a bunch of different things together. Is this ultimately going to save us time in the long run? Big time, big time, big time. Okay, if you have done g composed with f, awesome. I'll come around and check it. If there's somebody that's done with a and b, I'm going to get one more up here. A little bit more difficult, but if you haven't done b yet, I want you to work through that one. Cool. Last one I want you to do is f composed with f of x. I'm really worried about a and b. C is there in case somebody looks at it and goes, oh, I don't like it. Or that if they did it already and they're just waiting, I want you to try C. I want everybody to try B to begin with, though. We are looking for G composed with F. I'm trying to remember where we put them. Did you have the exit tickets with the application? Do you still have them?
Yeah.
Can I use them? Do you mind? Awesome. Perfect. Okay. I'm going to have each table share. But I understand exactly where they come from. First thing I really want to clarify, when do I write in pink? To think, is this really part of our problem? No, this was just me going back and showing that it did what that mapping stuff that we saw on Thursday does do. This, I should have been more specific, is the real answer that we're after. That's it. So we'll look at F composed with F here in a second. But the mistakes that I'm seeing, I'm going to tell you, I think they can be remedied just by following the way and what this function really means. They're hard to think about sometimes, but if we go step by step methodically, we're going to avoid these mistakes. The first thing I always want us to do is I want to rewrite this. How do I rewrite G composed with F? G of f of x. Now, if we need to use bigger and smaller parentheses to make this look a little bit nicer, I would encourage you to do so. That is always the first line that I want you to have. Now, you don't really have to use the color system. Like, that's fine if you do or don't. It helps me. I think it'll help you as well. We're going to go one more line before we just start plugging in. G of, if only I knew what f of x was. I'll go up a little bit. Love it. Okay, we're going to write the same thing or similar thing for this one. This statement, it means something very specific. And I'm going to write it again because you guys have to. This thing right here very specifically means anywhere there is an x in, which function are we plugging this into now? G, right? Anywhere that there's an x in function, and I'm going to write this function g instead in case people are getting hung up with g of x part. Anywhere that there's an x in the function g, what are we going to replace it with? With x squared plus 3x. Now, for this, I happen to have the functions up on the board. You guys have them in yours. What I mean by this is now, once I have all this written out, I'm just going to rewrite g, because that's the one that we're evaluating now. We've already plugged in the other one into it. We put it inside. And let's just work it out. G of x is 3 times x, which we're going to plug something in for that, minus 4. What are we plugging in for that x? Every x in the function g. Oh, x squared plus 3x. Once we've plugged it in this second time, is there any obvious algebra that we could use to clean this up? Distribute. And I'll switch to green here just so it's consistent. What's 3 times x squared? What's 3 times 3x? And that minus 4 still comes along for the ride. Now, do you guys want to verify that this works again using the mapping idea? Or did the mapping idea up top where I did it with f of g of 1 confuse everybody? I can't tell. I asked two things and I phrased it like a yes or no, so of course I'm getting weird. Should we look at it? No, because it's complicated, or no, because you understand it, we don't need to look at it? Okay, so we're going to try one more time then. Like, we're going to hit it again. In this, what function happens first? F happens first. So we're going to take something from F. Give me a number. And let me change this to pink so we don't think it's the same part of the problem. Let's plug something in. So here's some domain of F, and we're going to take F here, and it's going to go to G, and then we're going to plug this in, and it's going to spit out something else. Give me any number. So I heard 0 and I heard 6. Let's do a 6. If I plug 6 into my function f of x, where does it take me? 6 squared is plus 18. $54. So when I plug in a 6 into f, it spits out a 54. Can I plug a 54 into function g now? And what's 3 times 50? 150 plus 3 times 4. Excuse me, just so I can do this. So that's 162 minus 4. It's 158, I believe. Okay, smaller numbers would have been nice. Now, we can do it bless you, we can do it with 2 steps. That's fine. But what do you think we're going to get if we did f of g of 6 and we just plug 6 in here? Where does it say if I plug in a 6, where should I wind up? At 158. Let's check that. What's 6 squared? Times 3. I think it's 108. Plus 9 times 6 is? Minus 4. And what would we get if we just did 108 plus 50? And we're here. Okay. Whoops. We clearly need a little bit of practice. Maybe having a real world application will make a little bit more sense of this. I want you guys to talk this problem out together. Ooh, do we want to go to the boards? Tomorrow.